One of the biggest factors in choosing a new vehicle is safety. And when it comes to avoiding accidents and protecting the occupants, Toyota employs smart thinking and very sophisticated technology. Technologies you may not have even heard of. From airbags to vehicle stability control, here's a look at Toyota's latest and greatest safety technology. Airbags are an important supplement to the seat belts, and Toyota's front airbags go one step further with dual-stage deployment and a front occupant classification system. Here's how it works. Dual-stage front airbags can deploy with lower pressure in less severe collisions and higher pressure in more severe collisions, so they tailor their response to the crash energy. The front occupant classification system has one job: to sense if the right front seat is occupied. If the right front seat sensor detects a lower range of weight or no passenger at all, the front passenger airbag is disabled and an airbag off light illuminates on the dash. If a higher range of weight is detected, the airbag is powered and an airbag on light illuminates on the dash. However, it's important to remember that even with this sophisticated sensor, it's always safest to place children under 12 in the rear seat. Vehicle stability control and traction control are completely automatic, electronically controlled driver's aids with two unique functions. However, both react in the blink of an eye. When a drive wheel begins to spin on a slippery surface, traction control steps in and automatically reduces engine power. If the spinning wheel has very low traction, brake pressure is applied to the spinning wheel, which diverts engine power to the drive wheel with better grip. Once the drive wheels regain traction, the throttle is gradually reapplied and the vehicle can smoothly pull away. In essence, traction control helps the engine to virtually feel the road surface and send power to the wheel with the best grip. Once the vehicle is underway, vehicle stability control can help the driver negotiate turns more safely by keeping the vehicle on the path intended by the driver. For instance, if the vehicle begins to turn too sharply, VSC can automatically cut engine power and apply brake pressure to the appropriate wheels individually, even if the driver's foot is on the accelerator. This can help to avoid a situation where the rear end of the vehicle swings wide, which could lead to a spin or loss of control. Conversely, if the vehicle is not turning sharply enough where the driver has the steering wheel turned, but the vehicle wants to push straight ahead, VSC can also automatically cut engine power and brake the appropriate wheels individually. The STAR safety system is an integrated network of 5 driver aids that comes standard on every Toyota SUV, Sienna, and the 2007 Tundra. STAR includes vehicle stability control and traction control, which was just reviewed. But it also includes the anti-lock brake system, ABS, electronic brake force distribution, EBD, and brake assist, BA. Unlike vehicle stability control and traction control, which will operate automatically without any driver action, ABS, electronic brake force distribution, and brake assist only come into play when you have your foot on the brake pedal. Electronic brake force distribution, or EBD, senses which wheels have the best traction. It then modulates brake fluid pressure so those wheels get a little extra braking power. For instance, a Sequoia with only the driver on board and no other passengers or cargo will have more weight on the front wheels than the rear wheels because of the engine. EBD would sense this and give the front brakes more power. However, if that same Sequoia was filled with 7 passengers and cargo, there would be more weight on the rear wheels because of the load. EBD could sense this condition and give the rear brakes additional power so the vehicle would stop more effectively. If the same driver encountered ice and snow when stepping on the brake, ABS would help maintain steering control by automatically pumping the brakes and helping to reduce the chance of wheel lockup. ABS can also pump the brake at a single wheel if that wheel is on ice but the others are on dry pavement. And if that Sequoia driver needed to come to an emergency stop, brake assist would step in. When brake assist senses the driver pushing the brake pedal in a panic stopping situation, which many people refer to as slamming on the brakes, the system automatically applies additional braking power if the driver didn't push the pedal hard enough for maximum stopping energy. These features all add up to a major benefit in driver confidence and emergency control. And remember, they're standard on every new Toyota SUV. Vehicle Dynamic Integrated Management is the latest evolution of vehicle stability control, traction control, brake assist, ABS, and electronic brake force distribution, which make up Toyota's brake control system. It smooths the transition between all 5 control systems and reduces the reaction time, which makes the system seem smoother and quicker acting to the driver. For more information on this advanced technology found only on Toyota's hybrid vehicles, see the Hybrid Synergy Drive Technology chapter. One high-tech suspension technology that you'll find on some Toyota SUVs is Toyota's adaptive variable suspension with height control. This reduces the compromise between off-road fun and on-road driving. To excel at off-road driving requires plenty of ground clearance. Traditional four-wheel drive vehicles have suspensions that raise the vehicle and increase ground clearance. On-road driving favors the opposite approach, a low suspension that keeps the vehicle's weight close to the ground. In the past, optimizing the suspension for one mode meant reducing its abilities in the other. Toyota solved this problem with adaptive variable suspension with height control. It uses a system of pumps and hydraulic oil chambers to raise and lower the vehicle at the driver's command and according to vehicle speed. It can also lower the vehicle when parked, so the floorboards and cargo floor are closer to the ground. This system provides 3 important benefits. It increases off-road clearance, it helps on-road handling, and it makes passenger and cargo loading and unloading easier. Fitting a large vehicle into a small parking space is a challenge for any driver. However, Toyota's intuitive parking assist can help with virtual eyes in the front and rear bumpers. Using sonar technology, proximity sensors in the bumpers can tell if the vehicle is getting dangerously close to an object. As the vehicle approaches a stationary object, beeping signals and an indicator light can alert the driver and help guide them into place. HAC and DAC are braking system features that help to make climbing and descending steep hills easier, both on-road and off. Beginning with HAC, sensors in the braking system can tell if the vehicle is rolling backwards when the automatic transmission is in a forward gear and your foot comes off the brake. When HAC detects this condition, even at speeds as low as 0.06 miles per hour, it automatically applies the brakes to control rearward motion. This gives you time to move your foot from the brake to the accelerator without having to use both feet. Plus, HAC gives you time to gently apply the accelerator, which can help to avoid wheel spin on slippery surfaces where getting a start can be especially tricky. Of course, driving downhill on a slippery surface can be tricky too, which is why some four-wheel drive vehicles are equipped with DAC, which can apply the brakes and help the vehicle creep down a steep hill at a controlled target speed of 3 to 4 miles per hour. All it takes is shifting into L4 and pressing a single button. You don't even step on the brake pedal. This is particularly helpful on an icy driveway or a steep muddy trail, where the wheel-by-wheel braking can help the driver maintain steering control and help keep the vehicle from sliding or skidding sideways. DAC can even help the driver in reverse. Many Toyota vehicles come standard with a tire pressure monitor system. This helps warn drivers they have a severely underinflated tire. Toyota uses 2 types of tire pressure monitoring systems. The basic type uses the anti-lock brake system's wheel speed sensors to detect differences in tire rotation speed. A tire that is significantly underinflated will rotate faster than a fully inflated tire. If the system detects a tire that is rotating more quickly and is seriously underinflated, a warning light on the instrument panel illuminates. This helps warn the driver so the tire can be inflated, repaired, or replaced. Other Toyota vehicles have a direct reading tire pressure monitor system. In this system, small sensors mounted inside each wheel relay pressure information to a receiver and computer in the passenger compartment. If the computer detects a very low pressure signal from one of the sensors, it turns on a warning light on the instrument panel.